So welcome to April's mid-month development update. Now, before we start, make sure you like, subscribe, and hit that bell so you can get alerted to all the latest video content that we put out on the IOG channel. Now, we'll have our regular update today, but as well as that, we've got some bonus content for you. We asked John to record a video on Plutus, and particularly what the Vasil hard fork will bring to the development of the platform. So that'll come a little bit later in the show. We'll also have Matthew on later, talking to just some of the projects building on Cardano. This time, we'll feature Ardana, Meld, MuesliSwap, and ErgoDex. That's all coming up later. But before all that, let's have a quick check-in with a regular team, well, almost regular team. Nigel is not here this week. He's having some well-deserved downtime before things really heat up. So, John, let's start with network performance. How's it looking at the moment?
Tim, it's looking really good. And I don't know whether load has dropped or we've just made the network scale really well. But at the moment, everyone's getting serviced in great time. All of the dApps are performing well and there's no backlog. So this is exactly what we want to see. And when I start looking at the metrics on the network, so I'm digging into how blocks are transiting, how long they're taking to reach 95% of the staked Cardano, or nodes, or SPOs rather, representing that, and how long blocks are taking to be adopted onto the chain, these metrics are looking great, around 2.3 seconds. And this tells us that the network is healthy, performing well, servicing all of its users in a way that we want, and ready to scale out further. So I think we're all really happy with it.
So Kevin, obviously a large part of this is SPOs upgrading their nodes to the latest version. How are we looking in terms of the network there?
It's looking great, Tim. So shout out to all the SPOs who are so on top of the game. What we're seeing from Pool Tool is about 69% on the latest release version 134.1, 22% on 133. And it's likely that the increasing adoption by the SPOs is the cause for the better performance that John has been reporting to you. We're expecting a new release soon, 135. We'll announce the exact date when it's ready, but there's absolutely no reason for SPOs to hold off. 134 is absolutely the right version to be on for the time being. And looking ahead of the Vasil hard fork, there'll be a few changes we're going to need operators to make to some of their scripting, just to deal with a few tiny changes in the way the node is going to work. We'll announce that ahead of time so that nobody gets surprised by that. We'll call that out on Discord, Telegram, etc. So keep an eye on that. Nothing particularly significant, but it's just to make sure everyone's node keeps working perfectly through the Vasil hard fork and beyond.
So John, the network's looking very healthy, but we're not stopping there, are we?
Just to quickly build on what Kevin said, we want people to be on the latest and greatest. Just like companies like Apple and Google when they release their OS, they want to make sure there's not fragmentation. If folks choose to use the latest version, they're getting the best, and the network benefits as a whole as more people adopt. So I'd encourage people to upgrade. We're not stopping there in terms of scaling out the network. So just a quick recap, we've taken blocks from 64 kilobytes to 80 kilobytes. We've taken mem units from 10 million to 14 million. And most recently, we took block level limits on Plutus memory units from 50 million to 62 million units. These are real material changes. But coming up, and I believe just signed off and we'll be posting, I think next epoch, we're taking the block size to 88 kilobytes. So again, this is a 10% increase in throughput on layer 1. So these are real double-digit increases. And I think we don't actually need it right now with the current load we're seeing and everything is being serviced well, but we're not waiting. We want, as I mentioned before, the network to scale as demand grows.
So John, we're looking good for the Vasil hard fork. Perhaps you can just tell us a little bit about what's happening next, and I believe we've got a date we can share as well.
Absolutely. So just to remind people, we can make releases, and we do all year round. When we have a hard fork, what we're saying there is the protocol is changing in a material way. So we're leaving the old version of Ledger behind and we're moving to a new version of the Ledger. And this event requires all of our SPOs and all of our users to upgrade to the latest node so that they can fork together. This is an upgrade event and it's a positive thing. We only need to do this when we're making significant changes to the Ledger. We've just gone code complete for all of the stuff we're bringing in the June Vasil hard fork. The thing to remember here is, it's not just hard fork items that we're bringing. We're also bringing a slew of new features and fixes and enhancements. But alongside those things that we'd have in a normal release anyway, we also have these hard fork items. So just to remind folks, it's stuff like enhancements SIP 31, 32, and 33, reference script, inline datums, and reference inputs. And I've talked about this before, and I'll talk about it again. These are things that are going to make apps sing on Cardano. And these are things that are going to make developer experience easier and better. We're also bringing pipelining, which is our enhancement to lock diffusion, which will allow us to scale even further. And as I've mentioned before, this is going to see us right up to the point where we release input endorsers, which is our next generation strategy. So we're code complete now. And what does that mean? It means that we've actually coded, or not me, the smart people who work here have actually coded all of the changes that are required for these features. So they're in GitHub. The code is complete. But what we now need to do, because that's of course a great milestone, but it's not the whole picture when you're releasing something that has to be as robust and secure as Cardano. So we're now moving to a really deep QA. We're going to make sure everything is perfect. We're going to make sure there's no bugs, regressions, performance, slowdowns, etc. As we add all of this stuff, we have to make sure we're just as good as we were before we added it. So we're in that process of QA right now. We're in the process of integration testing, which means we're letting disparate parts of the system, like Ledger and Consensus, meet each other with these changes for the first time so that they can see if they're interacting correctly, which we're not anticipating any problems with, but at the same time, it's still a lot of work we have left to do. We've also reached out and talked to our partners and exchanges to make folks aware that this is happening. As an end user, you're not going to see much friction in terms of a user experience. You just download the new node, you fire it up, and everything will be under the hood. But exchanges and other businesses have to prepare for this because we need them to be upgraded on time so that there's no discontinuation in their service for their customers. We're going to have a testnet ahead of time to help developers and exchanges play with this stuff so that they can understand it, prepare for it. And ultimately, just to remind people, these cool changes we're bringing for Plutus, you need to take advantage of them actively. This is not a passive thing. So your apps that are currently there are not just going to, use these features automatically. If you want to use reference scripts to make your app lighter, you've got to do that. If you want to use reference inputs so you can do more reading of UTXO values and datums concurrently, you've got to take advantage of that yourself. So these are things that we want folks to use, and we're going to have lots of information around how to take advantage of them so people get the best experience. And then finally, just to add, we're targeting a date in June, and I don't like giving dates because in engineering, it's one of those things, whenever you give a date, it ends up being a mess. But we're looking at June 29th. And some of you guys will be probably thinking, yeah, they said June and it's now June, the last possible day in June. And you're right, it is. So we're just giving ourselves as much time as possible to get all this work done.
But things looking very positive there, John. Thank you very much for that update. Now, John, just before we let you go, you've actually been kind enough to record a video for us. You mentioned the SIPs, you mentioned the Plutus improvements. We'll run that video in just a moment, but what are we going to be looking at there?
I realized, when we were discussing things internally, that we didn't really have a one-stop shop to understand Plutus, a single place folks could go and kind of get the current state of play. So what I wanted to do was bring people on a journey, a relatively short video, I think it's 15 or 20 minutes, where we would just walk through the entire ecosystem of Plutus. And I tried to explain it from the roots, right? I try to bring people on the journey of how do you create a dApp? Where does it start? What is the first process? File, new project, and you start writing your code. I then bring people on the journey of how we get that to the blockchain, how you interact with it. And then I finish off the video looking at some of these enhancements that are coming up and looking at some of the great reasons why building on a UTXO-based system like Cardano brings concurrency, parallelization, and other good things. I think people should like it.
So thank you, John, and thank you, Kevin, as well for those updates. So let's run that video, but please stick around afterwards. We'll have some more updates from Matthew and some of the projects building on Cardano right after that. Let's play that video.
Hi, I'm John Woods, Director of Cardano Architecture at IOG. And today I'm here to tell you a little bit about Plutus. We're going to be rolling out some major changes in June to both the Cardano platform and Plutus itself. Plutus is smart contracts. The changes we're bringing in June are going to mean huge enhancements for Plutus in general. And today, what I wanted to do was bring it back to basics. I think many times when we're giving technical updates, we forget to give the fundamentals about how things work. And today we're going to look at the fundamentals of Plutus. So the content today is roughly as follows. I'm going to give some context on what Plutus actually is. I'm going to talk about EUTXO, extended unspent transaction outputs, and they are the heart of the Plutus model. I'm going to talk about the Plutus architecture, how you interact with a Plutus script, our CIPs, or Cardano improvement proposals, and some improvements that are coming down the line. I'm going to talk about some of the virtues of Plutus, determinism, parallelism, and concurrency, and then finally wrap it up with a quick conclusion. Okay, so Plutus is Cardano's smart contract platform, and Plutus represents a range of technologies, but ultimately they empower the creation of dApps, or decentralized apps on blockchain. They also enable NFTs, non-fungible tokens, which have been very popular this year. They open up the door for a whole new range of collectibles and use cases. Plutus is also how you launch native assets on Cardano. And what does that mean? It means your own coin, your own token, your own currency. Plutus is the gateway to launch anything you'd like in that context. And then finally, Plutus allows arbitrary on-chain conditional logic. Now, what does that mean? Plutus enables effectively like Excel if statements, programmability on the Cardano blockchain. So now let's talk about EUTXO. EUTXO, or extended UTXO, is the difference between a standard UTXO model like Bitcoin and what we're achieving with Cardano. EUTXO is how we do on-chain programmability and smart contracts. So let's look at the components that make up EUTXO. We have the concept of a contract, a smart contract. It's sometimes called a validator or a script. And you can think of this as a lock that locks up UTXOs or locks up Cardano, ADA, or value on the Cardano blockchain. It can also be used to lock NFTs or other native assets, like your own coin that you launch. We also have the concept of a redeemer. And a redeemer is like a key. And the key, or the redeemer in this case, is the piece of data passed in by the user of the smart contract to try to unlock those funds and spend them. We have an item called datum, and datum is some state that lives on the UTXO output. And you can think of datum as a place to store a high score, or some metadata, or some other data that's important to your app. Datum is kind of like the hard disk for the smart contract. And then finally, we have a thing called context, which is really like metadata. You're able to inspect the transaction and say, hey, who signed this? What account is this spending to? That kind of thing. So if you wrap these four items up together, this forms the heart of what we call EUTXO. And it turns out that EUTXO is all we need to enable all classes of smart contract, DeFi, or other Web3 application on Cardano. Let's talk now about the Plutus architecture. I think the Plutus architecture is really interesting. And this slide walks you through the process of going from code to on-chain app. So we start, of course, with developers. Developers write the source code to the dApp. And all of the Plutus contracts are currently written in Haskell. We may support other languages in the future or allow DSLs to make things easier for certain use cases. But right now, we do them in a functional programming language called Haskell. So let's look at how you start with user code and you end up with an on-chain script. Well, it starts with the compiler pipeline. The Haskell code that's written by the developer is turned into a thing called Plutus IOR. Plutus IOR is an intermediate representation. And those of you who might be familiar with how things like LLVM work will know this already. When you write code, of course, it goes through a pipeline in all contexts, whether that's smart contract code that's destined for blockchain, or indeed a Windows or Mac OS or Linux app. When we get the intermediate representation, it gives us an opportunity to mold and make more efficient the source code that was written by the developer. And this is really important because how we represent the application in a machine language that's going to be executed at runtime is really important. So by taking the Haskell source code and by driving it through a number of optimization stages whilst it's in this intermediate representation, it yields really fast performant apps. From that intermediate representation, we then go to type Plutus core. Now, type Plutus core is just before the raw ones and zeros that get executed on chain. So why do we have it? Well, it's a handy item for developers. Type Plutus core is really low level, but it still has some extra information that developers can use to debug. Finally, then we move to onType Plutus core, which is a lambda calculus variant. I'll let you Wikipedia that, but it's basically a logical way to express the app. OnType Plutus core gets executed on chain. So how does that OnType Plutus core or compiled app get on chain? Well, after all those optimization stages I talked about, scripts get on chain with toolkits and other Plutus apps. We have a whole suite of applications that help you take that compiled application and inject it on chain. Of course, it's really important to mention off-chain code. So even when the on-chain code is written and has been compiled and is ready to go on chain, we still need an off-chain component. The off-chain component is the application that will correctly form transactions to interact with that on-chain app. So the on-chain app can be great, but we still need something that helps us build and form correct transactions that provide the inputs to that app. Inputs like the redeemer and the datum that we talked about in the previous slide. So I think this is painted really well. We start with user source code. We move through the compiler pipeline to make it as efficient as possible, taking that human code and bringing it down to the raw ones and zeros. We then end up with Plutus core scripts. We use our tools to inject that in a transaction on-chain, where that on-chain script will be processed by our Ledger API and ultimately executed and run by the Plutus core evaluator in a decentralized way. And of course, just to mention, the off-chain or contract monad, as some of you developers will know, is a way that you can then interact with this on-chain component by forming the right transactions. So let's move on now to Plutus interaction. So I'm drilling into how it looks when you're actually using one of these scripts and you're a user who wants to interact with a DEX or another DeFi app. So how do you interact with a Plutus contract? I think this is an interesting one because it differs from how it works on Ethereum, and it's going to change with our upcoming updates in June. So right now, you interact with a Plutus contract in the following way. You write the code, compile the code, generate the transaction. You then use Edwards 25519, which is an elliptic curve, and we use a signature called ED25519, it's a signature algorithm, to sign the transaction with your private key. That transaction is then submitted onto the chain, and then it's executed by the Ledger API. But I think there's an important thing to realize here. Plutus dApps or Plutus scripts don't go onto the chain until you're interacting with them. So you include the Plutus script in the transaction that you're submitting to the chain each time you want to interact with it. But this is going to be changing. Let's look at some of the SIPs and the improvements that are coming up. So we're making Plutus better. SIP 31 defines a thing called reference inputs. And reference inputs is going to make a huge change to how developers deal with interacting with UTXOs. I talked earlier about the datum, the data or the hard disk for the script, where you can store data like high scores, etc. Right now, if you want to read your high score in your dApp, you have to consume the UTXO and then recreate it after you've read the datum. Well, that's changing. SIP 31, which is coming in June, will allow you to read the datum or the data that's stored at a UTXO without consuming it and recreating it. And this means that multiple dApps can read from the same datum at the same time. And I think the benefits are obvious there. SIP 32 defines a thing called inline datums. So right now, that high score or that data that I've talked about, we don't actually store it on chain. We store a hash of it on chain or a fingerprint of it on chain. And it's up to the developer or the user to include it when they're interacting with the script. Well, no longer. You're going to be able to actually store the data on chain, moving much closer to a truly decentralized architecture. SIP 33 reference scripts, another critical one. On Ethereum, the contracts live on the chain, and you talk to them via a reference. Well, in Cardano, as I've described in the previous slides, we don't yet do that. We have to include the script in the transaction every time we're interacting with it. Well, SIP 33 changes that. You can now push a script onto the chain or a contract onto the chain, and then you can interact with it via a reference. So this is a very lightweight way to interact with a smart contract. Think of it this way. Rather than having all of the app logic in your transaction, you now just have a small address like an email address that you include in the transaction, and it points to the script that already exists on chain. Really cool. We're also bringing some other cool, geeky things around crypto. So Bitcoin and other chains can use different elliptic curves than we do on Cardano. We use, as I mentioned before, Edwards 25519, which is the same as other cryptocurrencies like Monero. But Bitcoin, Ethereum, and others use SecP 256K1, which is a Coblitz type elliptic curve. So we're going to bring built-in support in Cardano so you can interact with signatures from those other blockchains. And this could be done before if developers wanted to do it manually, but this is going to be a hell of a lot easier because it's built in. So it's a one-liner to interact with those signatures now. We're also bringing some really exotic stuff. We're bringing pairing-based cryptography. Now, pairing-based crypto is beyond the scope of this presentation, but we're going to bring support for fundamental primitives in the extension field for BLS 12381, which is a pairing-friendly elliptic curve. So this is going to open whole new classes of app. With pairing-based crypto, you'll be able to use homomorphically additive signatures to do some very cool stuff. We're making Plutus faster. The core interpreter, the thing that executes the untyped Plutus core that I described earlier on, or the ones and zeros, the raw app, that interpreter is being made faster and more performant. And this helps in a number of ways. It helps ensure that validation of blocks is quick and efficient. It helps ensure that the overall block propagation times are low. And indeed, it helps ensure apps get executed quickly. So we've made the script size, or the Lambda representation, 20% smaller in our next update. Our interpreter's a blazing 40% faster. And non-evaluation processing, so this is not running the code, but other things that it has to do, like data munging and cost modeling, that's 80% faster. So we're not resting on our laurels. We're making things better, even at core level within Plutus. One of the things that we've had some issues with has been collateral outputs. Whenever you're interacting with a Plutus script, you have to have some collateral as part of your transaction to cover the unlikely event that the script fails in phase 2 validation. What's phase 2 validation? Normally, when you have a Plutus script, we check before we submit it to the chain that it can definitely run to completion correctly. This is determinism, and it's one of the virtues of Plutus over other contract platforms like Ethereum. Well, that's great, but what happens if someone who maybe shouldn't be doing things like this created a transaction that they knew would fail phase 1 validation and submitted it to the chain? These things have happened with some bad implementations in certain wallets and certain hardware wallets. Well, in those scenarios, nothing too bad would happen, but ultimately the collateral will get taken. So you'd lose your collateral. It's like an overcharging of a fee. We didn't feel this was a great user experience, and we wanted the user experience to be really great. So we found a way to submit a transaction, including collateral, where the collateral that you include is just enough to cover what you need. And if you include more by accident, like 1 million ADA, you get back everything that's not required. So we now have a much better way to deal with collateral. This is all part of a journey in getting Plutus to be a great user experience. So even if people make mistakes, they don't get hurt. Let's talk now about determinism, parallelism, and concurrency. These are virtues of the Plutus platform, and this is the unique selling point. This is what's different about building on Cardano versus other platforms, and I think you're going to find it pretty great. So, determinism and validation parallelism. I'm glad I said that right. So, I'm not sure if how many users will have come across this, but there's a concept called a directed acyclic graph. And it's this idea that data can be thought of sometimes like a spider web. So you've got these little nodes, little circles, and they have lines to the next one and lines to the next one. And it's a big web grows. And we call this web or graph a directed acyclic graph, especially if it goes in one way. And it turns out that the Cardano ledger forms a graph of transactions. Well, graphs are great for parallel processing. Hydra does this. Chain revalidation does this. Cardano enables, by definition, parallel processing with the way UTXOs work. And this means that because Plutus core is deterministic, and because scripts only have access to local information, we can effectively parallel process many things during both validation of the Plutus script and indeed validation of the ledger. Let's look now at contention and application concurrency. So UTXOs can only be spent once. Applications or dApps that are built where multiple entities or actors try to spend the same UTXO simultaneously will contend on that UTXO or ultimately be blocked. So we can achieve better than this. When you're building on Cardano, you have to remember better concurrency can be achieved by using multiple UTXOs and exploiting the parallelism that I described in the previous slide. And you can build with this style a scaling architecture that's massively parallel and allows you to service all of your users at the same time. As well as that, coming in June, reference inputs, as I described earlier, will allow read-only access to datums that live on UTXOs to multiple apps at the same time. Let's wrap it up now with a quick conclusion. So, Plutus is powerful. And whilst different in execution to other platforms, Plutus is just as capable, if not better than the competition. Plutus is about to get even better than that though, both in terms of user experience with things like collateral outputs that I described and performance, as we've looked at with the enhancements that we're bringing to the Plutus interpreter. I hope you enjoyed this look into some of the fundamentals around Plutus, and I hope you'll enjoy building on what is going to be the greatest smart contract platform for the next 5 years. Thank you.
So, John, thank you for that. Now, do make sure you leave any comments and questions below, and indeed any future videos that you'd like to see. You never know, if we ask him nicely, John might do some more for us in the future. Let's talk about building on Cardano next. Matt's going to meet a few more projects in a moment. And if you want to try and stay up with all the incredible activity happening across the ecosystem, make sure you follow us on Twitter. We put out a regular thread there trying to capture at least a flavor of all the activity across the ecosystem. You can also try subscribing to our new Essential Cardano newsletter. The link is below for the latest updates on what's happening. Also below, you'll find a link where we're asking you about Cardano 360. We want to give it a bit of a spring spruce up, so please let us know what you'd like to see on that show. I'll leave Matt to close the show out now with some of the projects building on Cardano. We'll see you on the last Thursday of the month for Cardano 360. Thanks a lot.
I was glad this week to get a chance to speak with a few of the projects that have been on the show in the past. We spoke with Meld, ErgoDex, MuesliSwap, and Ardana. So Ken, tell us how things have been at Meld since you were on last.
Meld is a lending and borrowing protocol on the Cardano blockchain. And what we're trying to do is we're trying to create a full banking stack on Cardano, and that includes crypto-to-crypto lending and borrowing, and it also includes crypto-to-fiat lending and borrowing, algorithmic stablecoins, and other features and functions connected to banking, but more in the DeFi side of things. So we're working exclusively in DeFi, and we're working exclusively with non-custodial and decentralized technologies. So since I was on last time, we've had our token event. People are now able to have and use the Meld token. They can stake it in our app. You can use our app and connect it to the Nami wallet. Since the token launch, we've been had our head down and focused all of our attention on actually building the applications and tools. So we're building things like a bridge to be able to bring assets across from other blockchains. We're building frameworks to be able to show real-time graphs directly off of the Cardano blockchain. So we're doing a lot of things on the tech side, but we're also doing a lot on the legal side because we're touching fiat. We're dealing with regulations. We're applying for several licenses right now. We have a couple of really interesting announcements that will come out very soon. So if you're interested in knowing more and sort of keeping up, then you can come to our Telegram or our Discord channel. There you'll be able to find out a lot of details. On a sort of last note, we're also in the process of announcing some really interesting NFT stuff.
Thanks for the update, Ken. So over to you, Yasha. How have things been at ErgoDex?
ErgoDex is a non-custodial decentralized exchange which we are building on top of Ergo and Cardano blockchains. We also committed to bridge these two blockchains via our protocol to make it available to transfer liquidity among them. So we implemented an orthogonal to the pub framework, which allows us to programmatically create, sign, and submit transactions. The framework is based on Cardano node code base and has a good interoperability with the Plutus data model. We also implemented ErgoDex smart contracts in Plutarch, a low-level language with writing Plutus validators, which give developers fine-grained control over performance. We also covered all of the code base with tests. We implemented AMM bots in Haskell, and we set up to test all of the testnet infrastructure for ErgoDex on Cardano. We also implemented a scalable service for querying Cardano blockchain state, implemented ErgoDex SDK in TypeScript to create ErgoDex transactions in the browser. And I'm glad to announce that we have prepared everything necessary for the launch of the token. And we will provide you more information about that soon. If you want to find the ErgoDex community, you have to simply go to ergodex.io website, and there you will find all of the social media links and all of the community links. Oh, and I would like to add that currently we're working on Ergo mainnet, and also we are working on Cardano testnet, but the testnet is private, and within 1 week or 1.5 weeks, we will open it to public. And the next month, we will launch it in mainnet.
Thanks for that, Yasha. I think the community will be really excited to see ErgoDex on Cardano mainnet. So over to you, Samuel. How have things been at MuesliSwap?
Hi, so I'm Samuel from MuesliSwap. For those who don't know yet, MuesliSwap is a decentralized exchange on Cardano. And in fact, it has been the first decentralized exchange to launch at the end of last year. So at the end of last year, we launched a classical order book DEX. And since then, we've progressed quite a lot. So we've been able to really gain the support of the community. And then our big last 3 accomplishments are that we've released staking for the milk token, which is the governance token of MuesliSwap. Then we've also got our version 2 contract audited. So we'll soon release MuesliSwap version 2. And then most recently, we've also launched MuesliSwap Milkometer. This is a DEX on Milkometer, which is a sidechain of Cardano. So what you should look out for in the near future is MuesliSwap version 2. We are right now working full-time on it, and it will be a decentralized exchange like you used it from maybe Uniswap. So it will be automated market maker style. There will be liquidity pools. You'll be able to swap using those liquidity pools and also earn a passive income by providing liquidity there. So there's already a version on the testnet, and we'll release the version on mainnet very soon. So stay tuned for that.
Glad to hear that, Samuel. We look forward to seeing version 2. So Ryan, how have things been at Ardana?
Hi, I'm Ryan Matovu, founder and CEO here at Ardana. Ardana is a stablecoin ecosystem beyond just being a DeFi protocol built on Cardano. So we're building DUSD, which is a over-collateralized asset-backed stablecoin, and this is backed by Cardano native assets itself, a stablecoin backed by ADA. And we're also working on a decentralized exchange for highly capital efficient swaps between stablecoins and stable assets. So it's really building both the stablecoin itself and having that as a provision for the ecosystem, but also the infrastructure to transact and swap between stablecoins in a highly efficient manner. We have been under development for over a year now. And so far, the focus has been really working on smart contracts and bringing in interesting functionality beyond the stablecoin, such as users being able to stay staked with their original stake pool once they deposit ADA collateral. So this is a move by us to help, support the stake pools and allow people to continue that relationship. So going forward, our focus has really been on scalability for the system. That's for the stablecoin and how we handle liquidations, the decentralized exchange, and the number of transactions that we can, batch in to a single operation on chain, and really pushing that forward and anticipating the upcoming scaling improvements that we're going to see on Cardano, and making sure that our solution can leverage all of those benefits in the most efficient way.
Thank you guys for being on the show today and for giving us your updates. And thank you to the community for watching. Join us next time for more Building on Cardano.